All right.
We're back.
Good. Right, we're going to pick up in this session, we're going to actually do a little bit more networking, but this time we're talking about near-field communications.
So not all the way out to the cloud,
yeah,
but maybe just next door with your neighbor.
Now we're going down to a few centimeters, inches, as
I've got
we call
my
them
hot
here.
steaming cup of Microsoft coffee, and so I know I'm ready to go. Oh, but Andy's really doing all the work, so...
There we go. All right. So, yeah, this is all about NFC, near-field communication. So, Bluetooth and actual NFC tap-to-connect kind of stuff. So
it's an essential technology that any modern smartphone should have today.
And it's got some incredibly complicated demos. Well, actually, the demos are not complicated. Showing it to you and getting things to happen in the right sequence is kind of complicated. So, we'll see how we go with this.
Excellent.
Yeah.
I'm excited.
All right. So, this is what we're at. The agenda for this one, Bluetooth. From an application, it's Bluetooth and NFC. That's it. That's kind of what we're talking about. So this is a whole new API, some new capabilities for Windows Phone 8. We only had, obviously, regular network communications with Phone 7, but we've now got the ability to use Bluetooth, which can be used in two ways. Phone to phone, so app to app, shall we say, and phone to device, so you can kind of drive robots and
When you
stuff.
said app to app, though, do you mean app on another phone? From app to another phone?
That's what I mean.
Okay, not app to app on the same phone.
No, app to remote app.
Because we got so many people trying to find their way into some kind of inter-process communication. You know.
That's right. Yeah.
Gotta be clear.
Yeah. And NFC. So this is where you've got very close proximity. So, a nice picture.
That is nice. Yeah, that's lovely.
Lovely. It looks close. Yeah, there we go. Bluetooth then. Let's talk about. So first of all, we're going to concentrate on Bluetooth, and then we're going to talk about NFC. So they are related, but slightly different in the way the usage scenarios and the kind of things you can do. The most obvious difference is the range. So Bluetooth is short range, NFC is tiny range. So Bluetooth is normally up to 10 meters, but as it says, it can be reduced by conditions. So
of course, like walls.
Like walls, not good.
Lead.
Yeah, lead's really bad.
Things like that.
Yeah.
How do you think we protect the reactor from the rest of the submarine?
Yeah.
Seawater and lead. Anyway,
yeah.
Superman and kryptonite. All right, moving right along.
So we've got two specific Bluetooth communication scenarios we support. First of all, app to device. So this is where you've got something that must be paired. So the user, the phone owner, must previously have paired the phone with something like, and the obvious thing that people do is like headsets. You pair it with a headset, and that's what most people use it for. But you know, it can actually be paired to any equipment that's got a Bluetooth radio in it that is set up for pairing. So it could be they did a good demo at Build with a robot built out of Lego. So they have this robot thing, and like helicopters and all kinds of that sort of thing. I haven't got any cute demos like that, I'm afraid.
No helicopters?
No helicopters, no. But the key thing here is the phone must be paired with the device. Once that pairing has been done, then our software can talk to that remote device and can control it. The other scenario is app to app. So this is where a program running on a Windows Phone device can discover and pair with another instance of itself or an instance of its Windows 8 counterpart. So let's say, for example, you have created two apps, one running on the phone and one running on Windows 8.
Right.
So you can actually discover that instance on the other device and connect to it and communicate between the two.
Excellent.
So for that, obviously both apps have to be running, but the pairing doesn't have to be, there's no device pairing required for that. Just obviously you need Bluetooth radios turned on, duh. But other than that,
this would be perfect for that tic-tac-toe game you were talking about. We could play together.
I know, and I was going to write that, but we just ran out of time.
Like last night, just throw it together.
Yeah, so all good intentions.
Yeah.
Well, that'll come up, the networked tic-tac-toe one.
Right.
Anyway, when you've got a connection, the Bluetooth connection, you get this object called a stream socket, and that's actually the object you use to send and receive stuff on. So, yeah, the Bluetooth pairing thing. So for app-to-device scenarios, the device must have been paired with the phone previously. Device has to be made discoverable, obviously, before pairing. I'm sure you've all done this thing with headsets. So, yeah, you just have to kind of get it into discoverable mode, and then one device discovers the other, and sometimes you need to enter a little key, which is often 4 zeros, but might be something more
Very
sophisticated.
secure.
Very secure, yeah.
Yes.
So that's the device app-to-device scenario. And like I said, with the app-to-app Bluetooth connection, one app is looking for another instance of itself or its other Windows 8 version of itself on another device, and that doesn't need the pairing. So app-to-device. Nice picture of a robot there.
I love that.
Yeah. So an application running on a Windows Phone 8 device, first of all, gets a listing of all the Bluetooth devices that have already been paired with the phone where it's running, and then it can actually query the devices for services that it offers, and then attempt to make a connection to the required service on that device. There's a couple of capabilities you need to enable for this. There's ID cap proximity and ID cap networking must be enabled for this app-to-device scenario. I think the third bullet point there is rather unnecessary. This will not work if Bluetooth is turned off, children. So this is how you find the paired devices, ones that have previously been paired. There's a Peer Finder API, which we will see used a lot. And you have to first of all set this static alternate identities dictionary. You have to add an entry of that which is Bluetooth : paired. The value you set that to is not significant. You just need to create that key in this alternate identities dictionary, and then call the find all peers async method. It's an awaitable, so when that comes back, it will give you a list of the paired devices. Now that exception you can see there, this is the rather ugly way that we just find out if Bluetooth is switched off. Unfortunately, there's no Bluetooth is switched off exception. It's a generic exception, but you've got to go look for that magic H result number. If you get that, obviously you could then turn Bluetooth on, which you might do using the connection settings task like that. So you can take from within your app, you can take your user straight to the Bluetooth settings and get them to turn it on. Or alternatively, an alternative to the connection settings task is to use the launch URI async with that reserved URI, which is the MS settings Bluetooth, which does the same thing. But either way, it just means from your app you can seamlessly switch the user over to get them to turn on Bluetooth and then try again. So let's assume now you called find all peers async. You get a list of peer information values back, a collection of these objects, each of which describes a paired device that was discovered. And that includes stuff like the display name, the name of the service it provides, and a host name value, which you need to save. Obviously, if there are no paired devices, that will just come back as an empty list. Then, having decided which peer you want to connect to, so here we're just in this code sample here, we're just selecting the first peer. You can then new up a stream socket and call the connect async method on it, passing in the partner host name and the partner service name that you've got from that peer information object, and that makes the connection to the remote device. So you get your stream socket, and then it's up to you then to implement. That's just like a pipe. It's up to you then to implement the particular protocol that the service on the remote device expects, and that's a case of just finding out what that is, implementing that code yourself. Now I haven't got a demo for that. Like I said, I haven't got any helicopters or robots, unfortunately. No, I know. But we're going to go on to app-to-app communication, which is kind of interesting as well. So this is where you, like chat or multiplayer games, like over Bluetooth. This is kind of what thing you would use this for. So
remote
the sample
procedure calls?
No.
Okay.
App-to-app communication allows two programs. Just behave, Rob.
All right.
An application can wait and respond to messages from another application. So again, we use the Peer Finder class, but we use it in a slightly different way. You need the ID cap proximity capability, and like I said, you actually don't need these devices to be paired in order for this to work. You still get a stream socket. It says socket stream. You get a stream socket that links the two programs, and then again, it's up to you to implement that protocol on the wire, on the wireless, in fact. So in this case, what you do is, first of all, you need to hook up an event handler for the connection requested event. So that's where somebody else has connected, is requesting to connect to you. That event will fire. You'll set your own display name. Here we've set it to PSR. And then I'm not sure the significance of that, I'm not sure there is any. And then you just call the start method. So the start method, that's where you start advertising yourself to other peers. So other people can discover you and could connect back into you. So then that connection requested, this is where you're going to get notified that another device wants to connect to you. And of course, when you get that event handler fires, then your code can, you can actually put some UI up to your user saying, so-and-so is trying to connect to you. Are you okay with that? And they say yes, then you make the connection. So this is an example of that. Here we've got an incoming connection coming in from, which has got a display name of Rob's phone. Here we're not bothering to ask for confirmation. We're just going ahead and saying, yeah, cool, we like Rob's phone. We're going to then connect back to that guy who's just connecting to us. So you call the connect async method for that, passing in the peer information object that you've got from that connection requested event args object. Then you probably want to call peerfinder.stop. Now it's important to understand that when you call peerfinder.stop, that doesn't drop the connection. Far from it. What that does is it stops the broadcast to say, "Oh, I'm available for connection." So it's, you know, for efficiency, you're saving battery by doing that, and making sure that no other peers could try and connect into you. So that checks the incoming request. We're limiting it to a hard-coded Rob's phone and this kind of thing, and this is where we make that connection to create that stream socket, and then this is where we prevent further requests and also improve our power consumption. And then you've got a stream socket, so it's up to you then what you do. So you need to implement some kind of protocol between the two devices now, between the two instances of your app. And this is about as simple a... I just seen on the... I've completely stopped there because we just heard from Rob Mars. Hi, Rob. Good to hear from you.
Hi, Rob. How you doing?
How you doing? Yeah, he sends his best wishes to everyone out there in Planet Jumpstart.
Oh.
And he also wants to ask the audience, and it's gone off the screen, which cheese is made backwards? See, I know this. Which cheese is made backwards?
I have no idea.
Anybody watch this? Which cheese is made backwards?
Oh.
Made.
Edam?
Edam, yes!
Yes!
Now, this warms my heart. Thank you, Rob. We did not have enough bad jokes in this episode, so yeah.
I've really been falling down on the job with the bad jokes. I apologize. Now we've got the Edam. Excellent.
Yeah.
I've been waiting. Can I get that sandwich down in the cafeteria?
Yeah.
Okay.
No, not yet.
All right. They'll probably start carrying it now, though.
All right.
Now that Rob Miles is in the house,
now the Rob Miles,
they're going to start carrying that cheese.
This was getting kind of dull. This is a protocol here. We're exchanging messages, and we're using a data reader. And the data reader, our little simple protocol here, every message, first of all, has 4 bytes on the beginning, which is the length of the upcoming message. And then you have the message. So the protocol is, on the reader side, first of all, read the first 4 bytes, find out how long the rest of the message is going to be, and then read that appropriate number of bytes in. How hard could it be? So this is where we new up our data reader, new it up there. This is where we read in the first 4 bytes, and that we turn that into, we read an integer, and then we load that message and read the string. So there we go. And that's how you would actually call that get message. On the sending side, we have a data writer. So this guy...
Get out of town.
No, I know. We new up the data writer. We write to that stream the length of the upcoming message, so we write an int32 to it. Store async, which actually writes it to the socket, so that gets sent over. Do the same with the write string, so we actually then write the message to the pipe and store that onto the data writer. So that's how we write on the writing side. So this one is not implemented as an awaitable. The receive one was. So we just call it whenever we've got anything to send. Whereas the other one will just, it won't block. If it's an awaitable, it will wait until it's got something to read, and then it will call you back. So that's the beauty of async await, folks.
It is.
It doesn't block.
Like message queuing.
Yeah.
Knack.
Yes, that's right. So messages and protocols, the send message and get message methods, together implement this really, really simple protocol. Now then, Rob, I need your help.
Uh-oh.
Yeah, so it's demo time.
Excellent. I'm excited about this.
And I have to have instructions because this is incredibly complicated. So...
Oh, good thing you have me helping you then.
Yes, that's right. So I've got 2 devices here.
All right.
One of which is got the video out, and one of which is actually my personal device.
Right.
They're both Lumia 820s. And what we need to do is connect the second start.
Yada, yada, yada.
I'm going to start this running on one of the devices, which is where I find out which device is connected to which cable. Oh, there we go. Okay.
Oh, excellent.
So,
while he's setting this up, I'm going to go to Holland to get that cheese.
why is this showing on here? That doesn't make sense.
Now, there it is. As soon as they go, what?
What?
Why is it showing that?
Yeah, I said it was complicated. It's like I said, it's not a complicated demo. It's just that
Yeah.
it's so complicated figuring out. Oh no. Okay, no, we're good. We're good.
Oh, we're back.
We're good.
We're good.
So this is debug on my device, and I haven't got video out on that, so I'll just have to tell you what's going on.
It's going to tell you.
Yeah,
Don't
but-
you love demos where they just kind of tell you what's happening? Just believe me.
But this one, yeah, this is the one I want you to run.
Okay.
And I'm just going to start the right app,
Excellent.
which is the.
You've got a lot of apps.
Yeah, that's right.
You're really into this phone thing.
So there you go. This is a chat thing. So don't do anything yet. I'm just going to shrink this down a bit so that we can actually see what's going on in Visual Studio as well. So so we got two. So Rob's on the other device, and we've got our cables all tangled up here.
Uh-oh.
Oh,
That's not
we're good.
All right.
So at this point, hopefully you've got JumpStart. If you want to just hit join, so you're going to join the.
All right, I'm joining.
Yeah, and
I'm finding a peer
it's
right
looking
now.
for peers. Yes, there aren't any at the moment because
Hello,
I
peers.
haven't joined the same thing. So I'm now going to just make that a bit bigger so we can see that. There we go. No peers found. I'm going to join the same. I'm hitting the same button,
Okay.
and we're hitting a breakpoint because you're actually now requesting to connect to me. Okay.
Oh, so I didn't stop requesting.
No, you didn't stop because
All right.
you'd already hit this. You'd gone through this code here.
Okay.
So and then let this run. So no, that's me making the connections. Okay, so now if you do a refresh peers, you should be able to
All right.
find that I'm there.
All right.
Yeah.
I'm refreshing. I'm finding.
Oh,
Oh,
there you
look
go.
at that.
So now I hit connect to selected, and you're now going to connect back to me, and we should hit. There we go.
Oh, look at
Yeah,
that.
So
Look at all
we're
that
into
yellow.
yeah. So we're in yeah. It's not pretty. We're in the connection requested event handler. So I'm just going to step through that. I've stepped through it. Right, let it run even. And I'm getting an incoming chat request. Do you want to chat with JumpStart? So this is the UI that the app is putting up. I'm going to say, yeah, okay. And now we are connected. Oh, now I've got connect to peer. So now we're actually setting up the stream socket between us.
Okay.
So
I just got that error.
you got an exception.
Result E_fail. You've
Yeah.
probably seen this on Failblog.
Yeah. So
All right.
why don't you just okay that?
I'm
and
going
then
to okay that.
hit connect to selected again.
All right, I'm going to do
But
that.
this time I'm going to. It's probably. Yeah.
There we go.
I'm just going to let it run because maybe we had a timeout.
It was probably a timeout.
Yeah. Let it run.
Yeah.
Right. There we go.
Excellent.
So
Join the conversation.
now we can chat away. You see.
All right.
So this is all over Bluetooth. So yeah.
All right. I'm going to say something to you. Oh, I have to actually spell it right, don't I?
Yeah.
You. Yeah.
Short.
Oh, but this is so funny.
And then we can just chat between each other, which doesn't make for compelling viewing. I know.
Oh, this is good stuff.
Yeah. How long is this?
And here it comes.
All right. Okay. Oh yeah, and I've got it. I'll come up on my screen. You'll have to take my word for it. Yeah.
Yes.
Yeah.
I can see it.
And I'm going to send you a message back. And this is the send message code. So this is that protocol that we just the data writer stuff. So we write the length of the message, store it on the wire, then write the message, and away we go. And you should get you've got the message I've sent you.
Rob Miles is in the house.
Yeah. Yeah.
Wow.
Wow.
Excellent.
Yeah.
I'm so
Yeah.
thrilled. He's here with us right now.
Yeah.
And
Party time. Yeah.
yeah. Well, that's the great thing about serializing,
Excellent.
deserializing.
Yep.
It's like beaming someone to another planet. So kind of we sent Rob Miles, we beamed him
Yep.
through these two devices using the socket. Right?
We did.
I mean,
kind of.
Isn't that what serialization is?
Yes, it
It's
is.
kind of like you take the human form, you know.
Where are you taking this?
Isn't that how we're going to figure this out for Star Trek? Basically, you turn people into byte arrays, send them over a stream, and then and then you deserialize them on the other side, rehydrate them into a person. What could go wrong? What could go wrong? Okay, I saw the early episodes of Star Trek. I know what could go wrong. All right.
Yeah. Okay, good.
All right.
All right.
Yeah, if you don't cast them back to the right person, then they might be, yeah. Anyway, moving right along.
Right. Well, there we are. That was okay.
That was.
Yeah. All right. So that was Bluetooth app-to-app communication. Doesn't work on the emulator. Needless to say. Well, it's not needless to say. I mean, you could have perhaps hoped that the emulator, maybe could have borrowed. No, it couldn't because it's virtualized and it's never going to work. Forget it. So that's Bluetooth.
That was great.
Now we're going to talk about NFC. So NFC, this is within 3 to 4 centimeters. So this is the tap to connect. You have to have the devices proximate. It needs to be close to each other. There's a theoretical data rate of up to 424 kilobits per second.
Yeah, we know about those theoretical data rates.
A practical one of a fraction of that, frankly. And it is assumed that this is intentional. So this is why there's no actual authentication, because you actually deliberately pushing 2 devices together. And it connects to another device with an NFC chip or a Windows 8 slate, or it can connect to an unpowered NFC chip or something like that. So it's quite nice for you could have NFC tags embedded in posters and you could read it and go to a website or whatever. So this is best for sending small amounts. So you're going to say something?
Or in an enterprise scenario, or if you're going into a warehouse and you're picking from bins that you need to do, you could read those that way, just like we would do with a barcode scanner.
Yep, too right.
I'm just saying.
Yes, that's right. So it's nice.
I can make anything into a supply chain management scenario. Just try me.
So there's 3 scenarios that we can use this for. First of all, is as a way of initiating a higher bandwidth connection. So you can use it to set up a connection. So it's a tap to connect kind of thing. So it will set up a Bluetooth it says Wi-Fi direct. That's actually not right. Or a Wi-Fi infrastructure connection. So if you're on the same Wi-Fi LAN or whatever, you can set up a Wi-Fi connection. Wi-Fi direct is supported by Windows 8, but not by Windows Phone 8.
Right.
Or you could read a tag, smart posters that have digital content in an embedded NFC tag, or it can be used for exchanging small amounts of data directly, like an electronic business card, V-cards, for example.
Do you think it would work with ad hoc mode on Wi-Fi? I don't know.
One to try.
We'll have to try it.
Yeah, one to try. Don't know. So 2 ways that an application can use NFC. Like I said, expanding on that. Simple message transfer. And to enable that one, you have to have a message type, and you have a publisher and a subscriber. An application can subscribe to these message types, it's just a string, and then receive that string message. Or you can actually use it as this tap to connect, which is our old friend, the Peer Finder API, can be used in this mode to quickly set up a stream socket between 2 devices. So you end up with the same scenario we looked at with the Bluetooth, except you're using a tap to actually initialize and set that connection up. So the first one, exchanging data. First of all, you're going to have one side of it is going to be a message publisher. So you have this, the API we're working with is this proximity device. You first of all call the get default method. That will return null if you haven't got NFC support on the device.
Of course, yeah.
But if you have got NFC support, you'll get an object back, and you can call the publish message method on that. And the first parameter will be the actual message type. So it's just a string, but it has to begin with Windows dot in order for this publish message to work. So it's got to be Windows dot something, and then what you put after that is entirely up to you. Okay. Your own unique string identifier message type, and then the actual data that you want to send across. And you get back an ID value. You need to save that because at some point later on you want to unpublish these things. So the publish message method is only for these Windows dot tags. There's a publish binary message and also a publish URI message that's interesting. The publish binary message is for kind of writing to NFC tags. I'm not going to go into that anymore in this one. Yeah, so you need to save that ID value because a publish is not a one-shot thing. Once you start publishing a message, it will be sent to every time your device thereafter connects to another NFC. So you keep on tapping devices together or different devices. It will continue publishing that same message until you call stop publishing message or you null out that device, that proximity device reference you've got. So on the receiving side, you'll need to subscribe for message, and obviously it needs to be the same message type. And again, you'll get an ID back, and you need to give it the delegates to a method that will handle that message when it comes in. And in this case, the method is called message received, and that one looks like this. So here we're just simply putting it up on a message box to say we've received a message, and it came from a sender with this particular device ID. And when you don't want to receive those messages anymore, you call the stop subscribing for message. So it's a mirror image of what you do on the publishing side. So a demo. I don't need you for this, Rob. I can do this one myself.
Oh, good.
So let's see where we're at. I've got a solution. I need to show you some code. NFC message exchange. So I've got two solutions in here. NFC message exchange, which is the sender side, and NFC message receiver, which is the receiving side. And the NFC message receiver first. I'm sure you won't be surprised to know it has all that code you just saw. So we subscribe for the message button. There's a button on the UI that's going to subscribe for a message of type Windows.JumpStart message type. And when we get it, we're just going to put a message box up on the screen. So I'm going to start on the device that you can see. Let's get this guy up. I'm going to start the, get rid of the Bluetooth sample. I'm going to start the, actually going to start the receiver on this device. I'm not going to hit subscribe for message yet. And on the other one, I'm going to start the NFC message exchange, which has a UI that looks like this. So we can put the message in this message box, hello JumpStart, and then we can call publish message. And the code behind that is this publish message button click. We get a reference to our proximity device, and then we if we've already been publishing the message, we stop publishing it, and then we actually publish a message of type Windows.JumpStart message type. And we also have got on that, we've got a third parameter. You can send the text, and I've also got a method that's going to put a message box up whenever that message is published. So you're not going to be able to see that one, unfortunately, but you can see the receiving side of things. So let's just start that guy running on the other device. So the receiving one, I haven't subscribed yet. I'm going to hit the publish message, and then I'm going to connect the devices together, put one right behind the other. And if you listen carefully, you should hear on my microphone the nice sound you get. So I'm hitting the publish message, and this is where we're into the starting the publishing code. So this is we're now publishing it. And I'm going to put the device behind, and you should hear the noise. You hear that?
I can hear it.
Yeah.
I hear it.
All right. But no message box. I've got the message transmitted message box has come up because it's trying to send it, because it will publish that message every time you've got a proximate device. But nothing came up on the screen. You see, now I'm going to hit the subscribe for message button and repeat. And you can see we've got the message box up because it's been transferred over. Do it again, and it comes up again. I've taken it away, and now I'm going to just do it once more. And of course, it just keep on publishing every time you bring the devices together. So there you go. Nice and simple, short message exchange just by tapping the two devices together. And if I stop subscribing to that message and put the devices together, of course you won't be surprised to know it's still NFC connects, but we don't get that message box come up anymore. There we go. So that was simple NFC exchange. But before we leave this thing, I've got another really interesting example. Now this is cool. So on the UI, now you see there, I have got on this device, I've got installed on it our old friend, the Contoso cookbook. There you go, you see it in the middle there?
Ah, yes.
Yeah, yeah. Now that is this is the version that is enabled for a URI association. So if it gets an incoming launch of a Contoso URI, Contoso Cookbook will be launched for that particular. It's actually a recipe URI.
Okay.
This is what it's registered for. Now, on the sending thing, you notice here. Stop it. I've got a third button, Publish URI, and the code in here. This uses a different method called Publish URI message. So what we've got here is we've got one device is going to publish a URI message, a recipe colon, to the other device. So let's run that on the one device, and then I'm going to publish that URI and then put the devices together so that they are proximate. And watch this. Oh, hang on. Get the screen up so you can see what's going on. And now watch what happens on the other device. So you get, this is coming from the shell, receive content. This will open an app associated with recipe. And you say, yeah, I'm going to accept that connection. And Contoso launches. Now, what's really exciting about that is actually what you think, what if Contoso Cookbook wasn't installed? In fact, let's just do that. I'm going to uninstall Contoso Cookbook.
Wow, this is a good use case.
Yeah, so it's now off the device, and I'm going to put the devices together. So we're still publishing that recipe URI to the other device, and look, search for app.
Whoa.
So now...
That just happened.
So now, if I do search, it will go off to the store, and it will find an app that is registered for the recipe. Now, of course, Contoso Cookbook hasn't been published, so it's not in the store.
It's not in the store.
But you realise what we've got here. We've now got a way of implementing a tap-to-share app.
Yes.
So if you've got a really cool app, and you could create this in your own apps. If somebody sees an app that you've got that they're using on a phone, you say, "Hey, that's really cool. What's that app called?" And you can just say, "Oh, hang on, there's this. I can share it with you." And effectively, you can just you can go into the settings, turn on a button which is doing that publish URI, tap the devices together, and it will automatically go off to the store and find them the app, and then they can install it.
Well, I'm going to start doing that with my apps because I want more people to buy my apps. So I'm just going to go to grocery stores and just go up to people here and just keep pushing that button.
Totally. Yeah.
Yeah.
Cool. So that's pretty
exciting.
Nice. That's nice. Yeah.
Way to make it real for us.
Yeah. Yeah. So the third scenario here is using tap to connect. So we're actually using tap to set up a higher bandwidth. So that's small strings. So we're using tap to connect and set up a higher bandwidth connection, a stream socket between the two. And the way we do that is we call peerfinder.start, but we need to hook this triggered connection state changed event. So this is for NFC tap to connect. And you can also, this is how you would do it, and this will work between Windows Phone to Windows Phone, but it'll also work between Windows Phone and Windows 8. And the way that, what it will do, sorry, look at the previous slide first, it will then go and start finding other copies of itself on the device that you have connected to. Yeah? But this one, it will actually go off and you can now tap a phone to a Windows 8 slate and it will go and find whatever the My Win8 app ID is. So you plug in there the actual app ID of your Windows 8 app and it will go and search for that one. So you can connect between a Windows Phone app and a Windows 8 app, obviously the same app, but the alternate identities is how you make that connection between the Windows Phone version of your app and the Windows 8 version of your app. And then you get this triggered connection state changed event, which will fire multiple times. First of all, listening is where it's connecting as host. Peer found is where the tap to connect has happened. And at this point, you can tell the user in the UI that they can take the devices away. So and it's connecting. When you get the completed event, that's when they can take that's when you've got a stream socket set up and you can take the devices away. And thereafter, you're working over Bluetooth or over Wi-Fi. Mm-hmm. And then there's a couple of other failure connection states you can get there as well. So this is how you select what the actual network connection is going to be that is set up. By default, both are true. So you can allow Bluetooth and allow infrastructure. On Windows 8, you can also allow Wi-Fi Direct, I think. So both set to true by default, but if you want to only allow one, you can set that to false. And Bluetooth is preferable, actually, it's more reliable than that. So the last demo I've got is quite an interesting sample, actually. So there is a sample called Pix Presenter, which you can download. It's one of the classic examples. Now, what is interesting about this is two things. First of all, it does this tap to set up a Bluetooth connection. The other thing is that this is an app that is using the same code base and builds both a Windows Phone 8 and a Windows 8 application. So the Windows 8 and Windows Phone 8, so here we've got the Windows Phone 8 client and we've got the Windows 8 client, and also there's a portable class library in there where a lot of the common code is. I'm going to talk about this afternoon in a bit more detail, but this is one example that you can download as well, the Pix Presenter. There's a couple of native things in there as well for doing black and white stuff. So I'm just going to, I haven't got a Windows 8 slate here, sorry about that, but I'm going to just run the Pix Presenter on a couple of devices. I'm going to run it on my own personal, we have to build it, on my personal device, and also over on the connected one. By the way, we're having a bunch of questions, and we always do get a load of questions about this remote viewer. Yeah, the DUV. This unfortunately is a tool that's not going to be on general release. There's kind of licensing issues, and
it's just for us. It's
I'm
an
afraid
internal thing.
Yeah, I know. There's a lot of people would love to get this for demoing stuff, and
right.
Unfortunately, not going to be available. So.
Sad face.
Yeah, sad face. I'm sorry, I wish we had better news on that, but that's how it is. So this peer connector actually is... just a minute, let's go to the projects and solutions one. Track active item, find that. Yeah, see this peer connector is actually a linked file. It's in both the Windows 8 version, we're looking at it here, and it's also in the Windows Phone 8 version. It's down in the view models, and it's exactly the same file, so it works. This is a case of sharing code between Windows Phone 8 and Windows 8. And this is the code where we're looking for a tap to connect. We're hooking up the connection, the update connection status, and we're setting up the alternate identities for both the Windows Phone 8 or the Windows 8 version of our app. This is what we're doing here. And then we allow infrastructure and we allow Bluetooth connections. And if it's NetFX Core, if it's the Windows 8 version, which we're not, even though it looks like it is, then we're actually into Wi-Fi, direct is false. And then this is our connection code, so I'm going to let that run. So PeerFinder is running on my one device. I'm going to run the Pix Presenter on the other device. Here it is. And we can go off and find a couple of pictures. That's nice. Oh, look, there's all my guitars. Actually, that's our band. That's my band. NIB.
See, he's really a rock star.
I am really a rock star. My stuff is the bass gear over on the right there. That's my, you can see my jazz bass guitar and an Ibanez one. Anyway, that's all very interesting.
It's very interesting.
Yeah.
It's the real you.
Yeah.
At some point, you're going to just have to really let your hair down.
I'm going to hit the connect.
And I don't mean figuratively.
And now we can tap to connect. We've put up a UI. This is UI we've put in the app as well. So I can now, we're going to tap and connect over Bluetooth. So I'm going to tap to the other device that you can't see. And we've got a UI and open app. Someone wants to use Pix Presenter with you. So I'm going to say, yeah, okay, we're going to set up the connection. And this is where we have now got our connection setting up. So I'm going to let that run in Visual Studio. And we have a connection set up, and I can now transfer. I'm going to transfer a photo from the other one. Oh, thank you. I was wondering why I was getting a blank screen. There we go. And we've now got a connection between the two. You can see a little Bluetooth symbol on top right there. And I'm going to send a picture from the other device over to the one device. This is working over Bluetooth. They're quite big images, so it takes a little while. So this will pop up in a moment, and we should see it come up on the screen. So perhaps a progress bar might be a good addition to this sample application at this point. So we do know that something is going on, and I can also send one back the other way. So the UI here. Oh, there we go. So there we go. That's a picture I took in the Alps this summer. Yeah. That's above Chamonix. That's pretty.
We love the Alps.
Oh, we do love the Alps. Yeah. So I can send one back the other way, so I can just swipe up the screen, and now I'm going to send the guitars back to the other device. But we won't wait to see that because you can't see the other device anyway. And it's just popped up on the other device. You may have heard a little bit of a bleep there. So that's Pix Presenter. There is a Windows 8 version of this. So this was covered at Build as well on the session of sharing between the two devices. So check that out, a bit more detail on how this was built. All right. There is good support in this for maintaining connection if you get made dormant or tombstone. So there's a technique for doing this. You need to save in your state dictionary the remote host name and the remote service name when you've got a connection. And then if you get made dormant and get resumed, you can then very easily recreate that stream socket using this code shown here. So you have to just new up a host name using the stored remote host raw name that you get back out of the state dictionary, and then call socket.connectAsync to reset that connection up. So you just need to put that code into your applications to recover from dormant and quickly and easily remake that connection. So in summary, that was Bluetooth. And that was NFC. We had a lot of fun with Tap to Connect and exchanging information, multiplayer games, endless fun you can have with this. So we're done on that session.
We're done. Just answering a zillion questions on this lovely Surface device. Have you noticed how cool this is? Yeah. This is for you people. All right.
So good. That's good. We are going to wrap now for another 10-minute little break. And then, what is it? Speech.
Is it?
Speech, I think, is next.
Wow.
Right?
I'm an expert on speech.
Yes.
So it's a good thing I'm doing that session. All right.
See you in 10.
All right.